Fusion 360's integrated concept to fabrication toolset treats components as fully flexible, making each one movable. Joints are used to establish positioning or motion behaviors between components, similar to assembly mates used in other CAD systems. Joints are applied a bit differently in Fusion 360, but they are much more powerful and flexible with far fewer clicks to get the outcome you're looking for. Unlike other CAD systems, joints can be used at any time during the design process in the same design canvas. You could use them to define a component's various position based on its motion and then keep modeling from there. Let's take a look at adding some commonly used joints to this telescope, and later I'll go over adding as-built joints to the model. Before I begin adding joints to the model, I'd like to point out that the tools used to join parts together can be accessed in the Assemble flyout menu. In this lesson, I'll be focusing on the top portion of the menu, tools that join parts together. As you can see here, this telescope subassembly's components can be separated from one another. I want these components to remain fixed to one another. A convenient way of fixing more than two components together is by creating a rigid group. This tool is found in the Assemble flyout menu. All you have to do is select the components in the canvas or graphics area and click OK. Now they all remain fixed as a group. Before I begin adding joints, I want to fix one of the components in space. This will make component motion much more predictable. I'll fix the support component in space by expanding the subassembly in the browser and then right-clicking on the component and selecting Ground. A pushpin icon appears on the component indicating it's fixed in space, which I can verify by trying to move it. Grounding and ungrounding components are historical features that are captured in the timeline. If you truly want to undo grounding a component without the timeline capturing the action, simply delete the feature in the timeline. Now, I can begin adding joints. Joints enable motion between components by restricting degrees of freedom. Compared to mating components in other CAD programs, creating joints in Fusion 360 is a new workflow. Let's take a deeper look. To add the first joint, I'll select the tool from the Assemble menu. The dialog box appears on the right, prompting me to select two components to relate. Also notice that the support appears transparent in the model. This is because it's grounded, and the first component selected to create the joint is the one that changes position. However, I can choose to use the support as the second component in the joint because the second component does not change position. Before I create the joint, I need to discuss how to use joint origins. Notice that when I roll over a face, an icon appears near my cursor that snaps to key points on the face. This icon specifies the joint origin that snaps the components together. The key points are automatically generated by the software and depend on the geometry of each face. When one of these locations is selected, the joint origin is set and will snap to the joint origin on the other selected component. Each joint origin has a specified orientation, and they will snap together so that the flat circular icons coincide with one another. This icon orientation is very important to create the correct joint alignment. In situations where a joint origin needs to be selected on a face not fully exposed, such as this cylindrical face, you can hold down the Control key or Command key for Mac users, and the face will remain selected in order to more easily choose the joint origin. For this joint, I'll select the center of the top face of the support, which becomes transparent to allow me to easily select the next joint origin. Then I'll select the center of the underside of the mount, and you can see that these two components snap together at the specified joint origins. More specifically, reference component 1 snaps to reference component 2, making component placement more predictable when creating joints. Next, I'll choose the joint type. This defines the degrees of freedom between the components. The first joint type, rigid, fixes the two components to one another and removes all degrees of freedom. When I select it, the joint animates to show the two parts fixed together as they shake on screen. The second joint type, Revolute, allows the parts to rotate about a single axis. When I select it, you'll see the two parts spin. This is the joint type I'll set for these components. Let's dive into the next joint type, the slider joint. I'll re-enable the joint command using the repeat command gesture. The slider joint will be applied to the slider ring and the support. I'll select the joint origin at the center of the bottom face of the slider ring, hold down the Control key, and then select the center of the support where the edge begins to taper. By changing the joint type to slider, I'm allowing the ring to translate along a single axis, which is animated in the model. I want to mention here that joint origins can be created manually if needed. This includes adding them in space between faces, as I'm doing here on the mount component. I won't go into too much detail about how to manually create joint origins. I just wanted to make sure you knew that this option's available when working on your models. To create the joint, I'll choose the newly created joint origin at the center of the mount. And at the center of the halter, then set it to Revolute, and the parts are related. Another common joint type is the cylindrical joint, which allows for 2 degrees of freedom, translation along an axis as well as rotation around that same axis. I'll apply a cylindrical joint between the telescope and the halter. I'll select the joint origin at the center of the telescope as well as the center of the hole in the halter by holding down the Control key, and choose cylindrical as the joint type. You can see in the animation that the telescope translates axially and rotates within the halter. At this point, I'll skip ahead to have all of the legs joined to the support using Revolute joints. The legs can now rotate about the support, but what if I want to limit their range of motion? This can be done by right-clicking on the joint and selecting Edit Joint Limits. The limits can be accessed in the browser, the timeline, or in the canvas. Currently, the part has been rotated to an angle of 90 degrees, which I will make the maximum angle. I'll set the minimum to 65 degrees to allow the leg to swing outward. This looks good, so I'll click OK. Before wrapping up, I just want to demonstrate how adding as-built joints allows you to relate components in context, on the fly. Because many models in a design are built in place, the as-built joint fully constrains components without needing to move them. This is slightly different than standard joints, which move components in the model in order to create the relation. Degrees of freedom are assigned on the spot in relation to neighboring components, allowing for proper motion. For instance, I want to add a linkage between this leg and the slider ring. Because I can add the as-built joint in context, the linkage will be created at the correct length the moment it's designed. I'll skip ahead to show the linkage created in the model. To add the first as-built joint, I'll select the tool from the Assemble flyout. The first step is selecting the two related components. Next, I need to select a joint origin as the position of the as-built joint, which I will add to the center of the hole in the linkage. Set it to revolute, and click OK. I'll create this same as-built joint where the linkage connects to the slider ring. First, I'll select both components, then the position for the joint origin, and click OK. Now, when I move the linkage, you can see that the leg, the linkage, and the slider ring all move together. This linkage and as-built joints can be applied to the other two legs, completing the telescope assembly and enabling the proper motion. One of the most useful applications of as-built joints is quickly relating imported models. For instance, this telescope subassembly initially had no component relations, just like an imported model. By removing the rigid group added earlier, I can quickly restrict degrees of freedom since all of the components are already properly positioned. First, I'll add a revolute as-built joint between the eyepiece and the small end cap. Then I'll add a rigid as-built joint between the small end cap and the tube. Finally, I'll add a cylindrical as-built joint to the tube and the lens fixture. As you can see, this is a quick and simple way of defining the motion of an imported model's components. As you've seen in this model, joints are a quick and flexible way of defining component movement. By snapping joint origins to one another, it's significantly easier to control component motion by choosing the joint type. Since these joint types can be changed at any time, the model's motion can be easily redefined. And in the case that you need to design new components in the model, as-built joints allow you to establish mechanical motion at any point in the design process.